So if you haven't seen the previous question, it's a good idea to start with that one. But it says calculate the delta G naught the reaction for the following reaction at 25 degrees C. Is the reaction spontaneous? So now you'll notice the table now has delta H, delta G, and delta S. All of these things are state functions, so we can use the same general formula. Delta G naught reaction equals the summation of N times the delta G naught of formation of the products minus the summation of N delta G formation naught of the reactants. So it's again products minus reactants, just like in the previous example, because these are all state functions. This is all perfectly valid things to do. Now, if you'll notice, the delta H's of elements is 0. The delta G's of elements are also 0. The delta S's of elements are not 0. So in this case, we want to find the delta G naught of the reaction equals the first product, which we have 2 moles of, times the delta G, which is minus 16.4 kilojoules. All right, minus the reactants. You'll notice in this case, the 2 reactants are both elements. So it's going to be minus 0. So we're forming 2 moles of ammonia from its elements. So the enthalpy of formation is just double the enthalpy of formation given, because this is the formation of 1 mole of the compound from its elements. We're forming 2 moles of compound from its elements, so we have to double it, and we get delta G naught of the reaction is equal to minus 32.8 kilojoules. This reaction, because delta G is negative, as we've talked about before, is spontaneous. So this is a spontaneous reaction with a negative delta G value.